Lesson 2.5 and 2.6, we're going to go over multiplying and dividing positive and negative numbers, but also combining like terms. Go ahead and write each of these statements down. Go ahead and write each of these statements down. These are the rules for multiplying and dividing positive and negative numbers. So if you remember, whenever we did lesson 2.2 and 2.3, we were adding and subtracting positive and negative numbers. So we said same signs, add and keep, different signs, subtract and take. Those are the rules for adding and subtracting positive and negative numbers. Today, we're going over the rules for multiplying and dividing positive and negative numbers. So the rules are different. So you have to know to be able to keep them separate, okay? When you multiply and divide by positive and negative numbers, all you have to do in order to find out is my answer going to be positive or is my answer going to be negative is look at your problem. If you have an even amount of negative signs, your answer will be positive. Remember, even numbers are 2, 4, 6, 8, and it can keep going, okay? But if you have an odd amount, 1, 3, 5, 7, keep going, your answer will be negative, okay? So if I had a problem like this, -2 times -4 times 6, what you would do at the very beginning, then you don't have to worry about it at all, is count up. How many negative signs do I have? 1, 2. So is that an even number or an odd number? Even. So I know no matter what, my answer is going to be positive. Now, obviously, you don't have to write a little plus sign, but I like to write it to remind myself. Then I can just multiply and not even look at signs. 2 times 4 is 8, times 6 is 48. Okay, but if I had this same problem and it looked like this, -2 times -4 times -6, how many negative signs do I have? 3. So is that an even or an odd number? Odd. So I know my answer is going to be negative. I go ahead and write that negative sign there, then I can just multiply the numbers and not even think about it. 2 times 4 is 8, times 6 is 48. Okay? So those are the rules for multiplying and dividing positive and negative numbers. So let's go ahead and do example 1. Now remember, you're not going to be allowed to use your calculator on your test or quiz. So we're going to get used to multiplying and dividing without a calculator. I promise I won't give you anything too terribly awful. Okay? First of all, let's count up. How many negative signs do I have in this problem? 1. So what is my answer going to be? Positive or negative? Negative. Go ahead and write that sign. Now it's in my answer. I don't have to worry about it anymore. What's 9 times 3? 27. Okay? Let's look at this next problem. How many negative signs do I have? 2. So what's my answer going to be? Positive. I like to write the little plus sign to remind myself you don't have to. If you automatically know it's going to be positive, don't worry about writing it. If you do write it, good. I mean, it doesn't matter either way. Okay? 8 times 1/2. What's that? 4. Basically, all you got to do is take half of 8. 8 times 1/2 is 4. Okay? 4 times 6 is 24. So my answer is positive 24. All right? Now, let's look at this problem here. This one's a little trickier. I have -3 to the third power. What that third power means is I have -3 3 times. So expand it. Write it out like this and then count your negative signs. Josh, how many negative signs do I have? 3. So what is my answer going to be? Positive or negative? Negative. And then I just multiply. 3 times 3 is 9, times 3 is 27. Okay, let's count up this next one. How many negative signs do I have? 4. So what's my answer going to be? Positive or negative? Positive. Now let's just multiply. 2 times 3 is 6, times 4 is 24, times 1 is still 24. Okay, so if I gave you a problem and it had 75 negative signs in it and we were multiplying, would your answer be positive or negative? Negative. What if I gave you a problem with 1,000,000 negative signs? Would your answer be positive or negative? Positive. Positive. Very good. Okay. All right. So example 2. Find the product with variable factors. That means now I'm adding some letters into it. So I'm really getting into algebra now. So even though we've got variable factors in this, the same rules still apply. I'm still multiplying, I'm still dividing positive and negative numbers. So I still have to count up how many negative signs do I have, and that will tell me. So let's look at this first problem right here. How many negative signs do I have? 2. So is my answer going to be positive or negative? Positive. Okay, so I can write a little plus sign, or I don't have to, okay? What is 2 times x? Can I actually multiply a number and a letter together and get one answer? No. How would I write those? Josh? 2x, exactly. Side by side. 2x, okay? Anytime you multiply a number times a variable, you just write them side by side. But let's look at this next problem. How many negative signs do I have? 2. So what's my answer going to be? Positive or negative? Positive. Now, I've got 2 letters this time, and they are the same variable. So how could I write this? Josh? Not 2n. That is a common mistake that people make. Look, our answer here was 2x. Does this look the exact same as that problem? No. So I know it can't be the same answer. In order to answer this, what you would do is you'd count up how many n's you have. 2, and I'd write n, and then that 2 is my exponent, n squared. So if you have the same letter, x, n, a, b, c, whatever it is, all you do is count up how many you have, and you make that your exponent. Okay, so if I had a problem like this, first of all, let's do one more. Count up how many negative signs do I have, Josh? 3. So what's my answer going to be? Negative. And then I need to write how many x's I have. Zach? 4. So how would I write this? Perfect. Negative x to the 4th power. Okay? Does everybody get that? All right, so let's look at this next one. Count up. How many negative signs do I have? 3. Okay, 1, 2, 3. So is my answer going to be positive or negative? Negative. Now, how would I write this? How would I multiply these? 4. I'm going to go ahead and write the 4 because does 4 have any other numbers to multiply with? No, so it's got to stay 4 because we can't multiply 4 and x and get a number. All right, now, how would I write the second part of this? Kyle?
Negative 4 to the 3rd power.
Not 4 to the 3rd power. What do I have 3 of?
Negatives.
Well, I have 3 x's, so I've got to write 4x to the 3rd power. Because that exponent goes with what you have 3 of, and I have 3 x's. Okay? All right, so example 3. They want me to evaluate the expression when x is equal to negative 7. So they want me to plug in a number for x. So they want me to actually do this so I can actually multiply and solve. Okay? But be careful, watch your signs. It's just like when we did those function charts, remember, x and y? When you've got to watch your signs. So let's look. They told us that x is equal to negative 7. So I've got 2 times, what does the x already have attached to it? A negative. So guess what? That can't go away. What am I plugging in for x? Negative 7. And I'm going to do the same thing. I've got a negative sign, and then I'm plugging in negative 7. Now, this is where using brackets would come in handy because you see that I've got 2 sets of parentheses, but it doesn't really matter. Now, 2 negatives side by side, what do I do? Anybody? Change it to a positive. So this is going to become a positive 7, and so is this. Change it to a positive 7. Now, does that mean I do 2 plus 7 plus 7? No, it's still a multiplication problem. Okay, do I have any negative signs at all? No, so I automatically know my answer is going to be positive. 2 times 7 is 14. 14 times 7 is 98. If it's easier for you to do 7 times 7 is 49, times 2 is 98, that's fine. Either way works, as long as you get 98, okay? All right, so let's look at this next problem. I've got to plug in my number, so I've got negative 5. What am I plugging in for x? Negative 7. Count up. How many negative signs do I have in this problem? Jocelyn? 3. So what is my answer going to be? Negative. Write that negative sign. You're done with it. You don't have to worry about it anymore. Now I just multiply. 5 times 7 is 35 times 2 over 7. Now, how would I multiply this? Because it's fractions, all right, and I don't have the use of my calculator. So what would I do to multiply these? Josh? Not turn it into a decimal. You can make 35 a fraction, and then you can cancel out. Because I say, okay, 35 over 1 times 2 over 7. Do I see anything that can cancel out? Yes. 7 goes into 7 one time. 7 goes into 35 5 times. 5 times 2 is 10. 1 times 1 is 1. Well, 10 over 1 is 10. And I remember about my negative sign that I had already figured out. My answer is negative 10. Okay? Example 4. Using the distributive property. Okay, distributive property is when I have got a number or a variable, okay, something on the outside of parentheses. Right here, I've got it, the 3 is in the front. Right here, the 7 is in the back, but it's on the outside of parentheses, and it is signifying multiplication. The distributive property always means you multiply. Always, always, always multiply. Okay? How I like to describe the distributive property is if I were to come in to class and I brought a bag of candy and I said, Kyle, would you like a piece of candy? He would say, absolutely, most likely. Okay? Everybody else in the class would go, what about us? We would like some candy too. Okay? Distributive property means I've got to give a piece of candy to every single person in the class. It would not be fair if I did not. You all would be probably pretty mad at me. Like, what did we do wrong? Okay? Same thing with math. I have got to distribute whatever is on the outside to everything inside of those parentheses. If I only distribute it to one term in there, your answer is going to be wrong. It doesn't work that way. Distributive property says it has to be given to everything, okay? And I know with distributive property I use multiplication. So I say, all right, what's 3 times x? 3x. Now, what's 3 times 1? 3. I keep my sign there because positive 3 times positive 1 is positive 3. And that would be my answer. Now, if you look, this next problem looks a little bit different because the 7's on the back, okay? What you can do here is move the 7 to the front and just rewrite it. Makes it really simple, right? Okay? Then I just distribute it to everything. 7 times x is 7x. 7 times negative 2 is what? Negative 14, exactly. Remember, I have how many negative signs? 1, so my answer has to be a negative. Okay, same thing with this next one. I'm going to move the x to the front. Now, if you can work with the x at the back and you say, oh, I like doing it that way with the x at the back, it doesn't bother me, that's fine. It's just different people's brains work different ways. I like to see the distributive property at the front. It's just how I like to do it, okay? So x times 2 is 2x. We always want to write the number first, okay? Technically, number comes first. Then x times 5x, how would I write that? 5x squared, exactly, because I don't have a number to multiply 5 with, so it stays the same. and I have two x's. So that would be 2x plus 5x squared. Okay? Next one. A times 2 is 2a. What would my sign be before I even multiply these next two variables? Negative. What's a times a? A squared. Exactly. Remember, you would not write that 2a. The 2 has to be written as an exponent to tell me I've got more than one a there. Okay? That is distributive property. Now, if I were to give you one like this is the one that messes people up. Okay? This negative 5 is still has to be distributed because of these parentheses right here tells me multiplication. So what you can do is write negative 5 at the beginning and do x plus 7. Then it looks a lot more like distributive property, right? I would distribute that negative 5 to everything. Negative 5 times x is negative 5x. Negative 5 times 7 is negative 35. Okay? So just make sure that doesn't mess you up where you go, oh, I need to subtract 7 and 5. No, that's not what that means. It means distributive property. Okay? All right, like terms, go ahead and write these down. So we're switching gears. We've learned how to multiply and divide positive and negative numbers. If I have two negative signs, what would my answer be? Positive. If I had 15 negative signs, what would my answer be? Negative, okay? So now we're getting into combining like terms. So go ahead and write each of these definitions down. All right, so I've written some example terms down here. You don't have to write them down. I'm just going to use them as visuals so you can see exactly what I'm talking about. But the first term that we have listed is constant. A constant just means we've got a regular number. It can be something like 5, it could be 100, it could be 1 million, but a constant is just a number that's by itself, okay? Now, when I have terms, remember when we said the different terms the other day on homework? When I have a term, that means a number and a variable here. I call them different things. The number that is in front of the variable is called your coefficient. So the number is called the coefficient, and the letter is called a variable. We've already gone over that, okay? So when I have a number and a letter side by side, I like to say that these are attached because there's nothing in between the two of them. The 2 and the x are side by side. So I like to say when I have a number and a letter attached, the number is called the coefficient, and the letter is called the variable. Now, these are more important for when you're doing your homework in your book and you're noticing that they're using this terminology. I'm not necessarily going to put these definitions on a test or a quiz and make you know them, okay? They're just helpful for you to have in your notes when you're looking back. However, this last term here is what I really want to spend some time on. Like terms. You have got to understand like terms in order to be successful in algebra. It's just bottom line, you've got to know how to do it. They're almost as important as positive and negative numbers, okay? Like terms have the same variable. What's a variable? A letter. They have the same letter, and that letter has to be raised also to the same power. So they are identical terms with just different numbers, okay? So, how I like to talk about like terms, and what we're going to be doing is we're going to be combining like terms, okay? Adding or subtracting them. And this is only dealing with addition and subtraction. Multiplication, you can multiply or divide anything. I can multiply 2x divided by 2, okay? I'm sorry, division. I could do 2x divided by 2 all day long. But when it comes to addition and subtraction, they have to be like terms. So how I like to describe this is, let's say me and Crystal are friends, okay? and you're friends with somebody who you have something in common with, all right? You're not going to be friends with somebody who you have absolutely nothing in common with. You don't like any of the same stuff. You're probably not going to hang out, okay? But me and Crystal are friends. We have something in common. We both like going to the movies. Now, when me and Crystal get together, is the fact that we like going to the movies going to change? No. That's why we are friends, technically. That's what we have in common, okay? It's going to stay the same. Like terms. What they have in common, this 2x and this 4x are like terms because they both have an x and that x is raised to the same power. There's only one of it. So when I add them together, 2x plus 4x, I'm going to add the numbers, which is 6, and what they have in common is going to stay the same. That is not going to become 6x squared. That's where most people make their mistakes, is they go, oh, well, I have 2 x's, so I've got to say that I have 2 x's. No. When you are combining like terms, what they have in common has to stay the same, okay? Now, I know that 2x and 2x squared are not like terms because I have x and x squared. Those are two totally different variables. So I cannot combine those, okay? I could only combine something like 2x and 4x. So they have to have the same variable or letter, and that variable also has to be raised to the same power. All right, so let's put this into practice. Simplify by combining like terms. So we've got to locate the like terms, and then we're going to either add or subtract them, depending on what they've asked us to do. So I have 4x minus x. Now, you're like, well, what good is that x because there's no number there? Okay, whenever there's not a number written, what is it? 1. It's an understood 1. This is my helpful hint to you. Write that 1 because I guarantee you I have this every year. People get going really quickly and they go, oh, 4 minus x is 4x. No, it's not. There's a 1 there, okay? So are these like terms? Yes, they both have an x. They both have something in common, exactly the same. So what is 4 minus 1? 3. And then their like term, which is x, is going to stay the same. So my answer is 3x. Now let's look at this next problem. Let's locate. What are my like terms? Josh? Very good. 5x squared and 3x squared. You say, well, what about that negative 7? He doesn't have a like term. He's a loner. He's all by himself, okay? So what is 5x squared plus 3x squared? 8x squared. Exactly. Do you see? She did not make that 8x to the 4th power. Whatever they have in common has to stay the same. Now, what happens to Mr. Negative 7? He just gets tacked onto the back. He's like that little brother or sister that has to tag along with you and your friends. Okay? All right, so he just gets tagged onto the back. Okay? Now, this next problem, you have got to pay attention to these because these are important. Okay? You would not go, oh, 1 minus 4 is negative 3. Wrong. If you do that, your answer will come out wrong. Okay? What I've got to do is I've got to remember, what did we do just a couple slides ago anytime I had a number on the outside of parentheses? Distributed. You have to do distributive property first. You may say, well, why? Why would it matter? Order of operations. Distributive property is what operation? Multiplication. Does multiplication come before subtraction? Yes, it does. So it matters. Your answer will change if you do subtraction before multiplication. So negative 4, so I just write this 1 there. Negative 4 times 1 is negative 4. Negative 4 times negative 2x is what? Positive 8x. Now you say, but I thought we couldn't combine those because they're not like terms. Remember, multiplication and division, you can combine anything together. Addition and subtraction is where you have like terms. Okay, what are my like terms now in this problem? 1 and negative 4. Guess what? Like terms can be numbers without variables. They're just regular constants. What is 1 minus 4? Negative 3. So I'd write negative 3 plus 8x. Now this time 8x is a loner. He doesn't have anybody to combine with. Okay? Alright, so that's how we multiply and divide positive and negative numbers and combine like terms.